Hi and welcome to Trig Equations Lesson 3. So we've covered the basics of trig equations so far, and what we've covered so far covers, I'd probably say, 50% of your trig equations type questions in your National 5 paper, okay? In fact, even more than that, okay? It's more likely to be the type of trig equations that we've covered in lesson 1 and 2. Now, in the next few lessons, I will cover trig equations, but they are more problem-solving questions, okay? And people do tend to be thrown when it comes to questions like this, okay? So let's have a wee go. I've got two examples I'll show you today, then I'll leave you some questions to try, okay? Right, the first example is this one here. Okay, you're looking at this thinking, oh, that looks like nothing to do with trig equations. It is. Okay, it's a very, very straightforward trig equation. The diagrams there is trying to confuse you, okay? So, we've got this curve y equals 2 cos x plus 6. That's that one up here, okay, the one with the curve, the U shape. And it says it meets the line with the equation y equals 5. So there's a straight line across the middle that has the equation y equals 5. And you can see that P and Q are where the line and the curve meet each other. We've actually covered something like this before in the quadratics and the straight line topic. We've done the exact same, we're actually going to use the exact same method, okay? The only difference being that it's obviously a trig equation. So we've got the equation is y equals 5, that's the straight line, and the trig graph is 2 cos x plus 6. Okay, points P and Q are the points where they meet. So at points P and Q, those two are actually equal to each other. Okay, now look at this equation. It says y equals 5. Your other equation says y equals 2 cos x plus 6. Those two are both y equals, so those two must actually be equal to each other. So what I'm going to write is 2 cos x plus 6. That's y equals, and I'm going to put it equal to the other one, number 5. Okay? You should recognise this as really just something simple like you have solved in lesson number 2. We've done questions like this, okay? How do we solve this? Well, we need to take it right down to x equals, or in this case, cos x equals, okay? So we're going to move this plus 6 across to the other side. So we're going to have 2 cos x equals, 5 is still there, plus 6 moves over, we're going to take away the 6. So really we've got 2 cos x equals negative 1. Cos x equals negative 1. What happens with the 2? Well, this 2 is 2 times cos x. Move the 2 over and we are going to divide by 2. Okay, so this is a point where you're looking to take your calculator because you've got cos x equals. If you've got cos x equals, we now want to do the inverse, or the second function that might come up in your calculator, cos to the minus 1. Remember, from lesson 2, we do not type in the negative, okay? And the negative, I mean the negative a half. We actually just type in inverse cos a half, okay? Right, let's see, calculator, and make sure you are on degrees mode. Make sure you've got a calculator that works. Oh yes, it does. Right, inverse cos 1 divided by 2, put it in bracket if it's a fraction. All calculators will work if you put the bracket in. Now, if I do that, I get 60 degrees. Now remember, in lesson 2 we talked about how we're going to get two solutions from these trig equations, okay? That solution I've got there is your first quadrant. Might not necessarily be one of the answers we're looking for. We need to look here. Look at the line where it says cos x equals. Is cos x positive or negative? Well, it says cos x equals negative a half. So cos is negative. And remember, this comes from here. Where is cos negative? Well, in the first, all of them are positive. So it's not the first we're looking for, not the first quadrant. So that 60 degrees is not one of our solutions. Where is cos negative? Well, cos is positive in the fourth one. That's why C is there in the fourth position. Cos is positive in the fourth. So that's not one that we want either. First and fourth, cos is positive. So it's actually second and third. Okay, remember how you get your actual second and third quadrant answer? I'm running out of space, so I'm not going to do the whole sum, but to get your second quadrant answer, we do 180 minus a calculator answer. So it's 180 minus 60. 120 is our second quadrant answer. And we're also looking for the third quadrant answer. How do you get the third quadrant? You do 180 plus. So it's 180 plus 60. There's our two solutions, 120 and 240. Now, before you move on thinking, oh yeah, that was easy, the question actually said find the coordinates of P and Q. A coordinate is an X and a Y value. Right, point P, that one there. Right, put your X value first. Your X values is P either 120 or 240. Well, P's the first one, Q's the second one, okay? So P's 120, that's our X value. What's the Y value that goes with it? Well, look, the Y value is, well, how far up is that? It tells you. Y is 5. Oops, that is a 5. And Q is the point 245. Okay? I'm going to show you another example. As I said, these are not coming up as often as your basic trig equations, but it is a problem solving question. It's solved exactly the same way. There's not a huge amount different there. But look at the next one, right? This is a bit more interesting. Right, I'm going to put on here, I'm going to actually write, it's a non-calculator one, just to get the brains working. And you're probably thinking, oh, how can I do non-calculator with trigonometry without a calculator? Well, it is possible, okay? This actually ties into another topic that you've done before, okay? You will see a wee bit more of this in the higher paper as well, okay? When it comes up to the higher course, you'll see a wee bit more of this. So this is a good wee start in the higher as well. Right, so it says sin x equals 3 over 5. Angle x is acute. There's angle x in a wee picture. It's a wee right-angled triangle. Find the value of cos x and find the value of tan x. Right, let's go back a bit, okay? We need to think way back. The very first time you done trigonometry, remember it was sin, cos and tan. And I'm not talking about sine rule and cosine rule. I'm actually talking about Roblox. Lovely. Oh, my daughter's Roblox obsessed. Oh yeah, Roblox, go away. Let's see. That's what I was looking to write. I've got all these wee notifications coming up on this iPad about Roblox alerts. I don't know if you're going to be able to see them. Right, they're away now. Right, this here should look familiar. Okay, SOHCAHTOA, trigonometry, right angle trigonometry, should look familiar. What this meant was sin x is opposite over hypotenuse. That's what the SOH meant. The next part, the cabbit means cos x equals, C for cos, A over H. That is an E. Okay. And the toe bit meant tan x equals opposite over adjacent. Does that look familiar? Not too sure if it does. It should. Okay. What these ratios actually refer to is when you have a triangle, imagine that's called angle x there. Which one's the opposite? Which one's the hypotenuse? Where's the adjacent? The opposite is that. The hypotenuse is across from the right angle. And the adjacent is there. I'm going to label these in this wee triangle I've got. Okay, so there's angle x. The opposite is the one with the 3. The hypotenuse is the one with the 5. And the adjacent is this one across the bottom. Okay? So the question says, find the value of cos x. Part A. Cos x. Well, what is cos x? Cos is adjacent over hypotenuse. Do we have the adjacent? Oh no, we don't have it. Oh, right, okay, we're going to have to work it out. Right, we've got a right-angled triangle. Okay? We don't know this bit. I'll call it A. Doesn't really matter what it's called. This is 3 and this is 5. How do we work out length A? Right, this is not trigonometry. It's another topic that you've done before. 3 sides of a right-angled triangle. You know 2. How do you find the other? It's Pythagoras. Okay, how do you find A squared? That is an A. May not look like it. Oh jeez, what am I doing? I want to rub out this wee bit. Oh, that's not a rubber. Oh yeah, it's a bit bare. Right, here we go. Let's see if it works. Right, oh, Right, so how do you work out 8 squared? A squared, do you do something to do with 5 squared and 3 squared? Okay, 5 squared, 3 squared, we square them and add them, or we square and subtract them. You square them and subtract them, do you remember that? And the reason why we square and subtract is because A is one of the smaller sides, okay? So it's 25, take away 9, which is 16. And this is where you probably realise, oh yeah, that's right, it's non-calculator. I'm going to fit it over here. How do you find A then? Well, it's the square root of 16. What's A? A's 4. So in this triangle, that A value is actually 4. So what's cos x then? Well, it's A over h, adjacent over the hypotenuse. That's the answer, 4 over 5. Okay, part B is going to be much easier now because we've actually got all 3 sides of the triangle, okay? Tan x, tan is opposite over adjacent. We know the opposite, it was actually given us to us in the question. The opposite was 3 and the adjacent was, well, we've just worked it out, A is 4, 3 over 4. That's your answer, 3 over 4. Okay, so this question involved basic trig, the sin, cos, tan ratios, and it also involved you knowing Pythagoras. You use Pythagoras to use your 2 sides to work out your third. Okay, I'm going to cite you a couple of questions just like this. Let me know if you need any help. Okay, best of luck. Bye-bye.